For question number 21, part A, we have to check where the function f of x is equal to x squared into mod of x is differentiable at x is equal to 0. So this is question number 21, part A, and our function is f of x is equal to x squared into mod of x. Now, here the mod of x, we know that it's the value is x when x is greater than equal to 0 and negative x when x is less than 0. Okay, so that means f of x is equal to x squared into x when x is greater than equal to 0, and this is x squared into negative x when x is less than 0, and this is now equal to x cubed when x is greater than equal to 0 and negative x cubed when x is less than 0. Okay, so let's check the differentiability. So we are going to find out the left-hand derivative. So left-hand derivative is given by limit x tends to 0 negative, and it's given by f of x minus f of a upon x minus a. So f of x here would be for x is less than 0 because it's x negative. So this is now limit x tends to 0 negative, and f of x is for x is less than 0, which is negative x cube. This is cube minus f of a. So a is 0, so that means f of 0. At 0, the value is x cube, which is 0 cube is equal to 0. So this is 0, and it's x minus a. So this is equal to limit x tends to 0 negative. This is minus x cube upon x, which is negative x squared. Okay, now let's say x is a small value less than 0, and as x tends to 0, h tends to 0. So that means the left hand derivative is equal to limit h tends to 0, and instead of x we can write 0 minus h the whole square, which is equal to 0. Now let's find out the right hand derivative. So right hand derivative is equal to limit x tends to 0 plus, so this is x, and formula is same, f of x minus f of a upon x minus a, but in this f of x would be for x would be the value of the function at x is greater than 0, which is x cube. So this is x cube f of a at x a is 0, and at 0 the value of the function is x cube, so 0 cube, which is 0, and this is limit x tends to 0 plus upon x minus 0, which gives me limit x tends to 0 plus. This is x cube upon x, this is x squared. Now let's say that x is equal to 0 plus h, and as x tends to 0, h tends to 0. Okay, so that means our right hand derivative is equal to limit h tends to 0 x square, which is 0 plus h the whole square, which is equal to 0. So that means the left hand derivative is equal to right hand derivative. So the given function is differentiable at x is equal to 0. Moving on to the b part.